All right, lesson 2 is on interpreting rate of change and initial value. Now, hopefully this isn't a brand new idea to you because we've been talking about rate of change and initial value. And like I said, a lot of what we're doing now is stuff we've been working on. We're just making some tweaks to it. We're thinking it a little differently. So I want to start with the equation we all know and love, right? Y equals mx plus b. Okay? We've been doing this for a long time. We know we can graph out of this. We know what our slope is and our y-intercept. And in fact, let's write that down, right? Our y-intercept, right, is whatever is being added on. And our slope is the number attached to our x, right? It's a number we're multiplying our x by because that slope is telling us what our x values are doing, what our line is doing, okay? Now we're going to tweak this formula a little bit. And now we want to kind of incorporate the y-intercept and the initial value. Initial value, and spell it correctly, right? Value. And our slope we're going to think of as rate of change. And our new formula is going to look like this. Y equals b plus a times x. And I'm sorry I'm squeezing this in, okay? But our initial value, okay, initial value is still going to be with our b, all right? It's what we're adding on, even if we're doing it first, okay? Which kind of makes sense because when we go to graph anything, we always start with that y-intercept or initial value. Our rate of change, or our slope, is going to be the number we're multiplying x by. So again, even if it's listed second, even if we're using the variable a instead of the variable m, don't stress about that. And again, guys, I'm sorry, I wrote that like so squished in there. It's b plus ax. We're not changing anything, okay? I don't know why the variable changes, but this is the formula we tend to deal with a lot. We're dealing with more real life examples, and it makes sense. We deal with our b first, our y-intercept, our initial value, and then we worry about what our line is doing, our slope is doing, our rate of change is doing, okay? It's really not different than what we have been doing. So just be aware that you might sometimes see it listed like this. It's kind of moving that way. All right. So basically, it says in a previous lesson you encountered an MP3 downloads of individual songs for a $3 fixed fee per monthly subscription, plus a fee of 25 cents per song. Remember, you see that word per? That means to multiply. Okay. Also, I know can mean to divide too, but in this case, it can mean to multiply. So the linear function models the relationship between the number of songs downloaded and the total monthly cost. So our cost is going to equal 25 cents times the number of songs plus 3, our monthly fee. All right, so X represents the number of songs downloaded, Y represents the cost in dollars. So in your own words, explain the meaning of 0.25 within the context of this problem. Well, we're talking about downloading songs and paying a monthly fee. And how much does each song cost us? 25 cents. So I'm just going to say we are paying 25 cents per song. I'm just going to point out here, guys, because I still see some of us doing this. When you use the dollar sign, it's to the left. It comes first. Okay, we don't use the cent sign anymore. That always came at the end. All right. So we're paying 25 cents per song. I want you just to tuck this in the back of your head here. Our cost is increasing. Right? The more songs you buy, the more money you're going to pay, right? So our cost is increasing 25 cents per song. Okay? So the cost is increasing. All right. So in your own words, explain what the meaning of 3 is within the context of this problem. Okay? This right here, well, it's just not, you can't just say it's our y-intercept because it wants to know within the context of the problem. Well, what does 3 represent? Okay? It's a fixed fee. So $3 is the fixed fee we are paying. Okay? Even for 0 songs. So it doesn't matter if you don't download anything, you're still going to pay that $3. You're paying a $3 fixed fee for a monthly subscription. You're getting $3 no matter what, and then you're paying 25 cents on top of it, okay? So it says the values in the function can be interpreted in the following way. So notice this $3 here is the initial value. Well, it's our y-intercept, but remember I've talked about our y-intercept is our initial value, okay? So this is where we're starting. If we want to figure out how much something's going to cost, we're starting with $3, guaranteed $3. And then the 25 cents is our rate of change, right? The 25 cents is going to change depending on the number of songs. That's why it's the rate of change. That's why it's the slope. It's the number we multiply by, okay? This number is telling us how much things are changing as time goes by. All right, because again, X represents the number of songs downloaded. So every song you download, you're going up 25 cents, okay? So again, these are more real life issues than just, hey, here's an equation, graph it, or what does this mean? So if it's more real life issues, we want to think about it more in terms of real life issues. And we want to focus maybe a little bit on what does it mean when things are increasing and decreasing. So the coefficient of X is referred to is referred to as the rate of change. Slope, unit rate, okay? But basically it's telling us how much something is changing. It can be interpreted as the change in the values of y for every 1 unit increase for the value of x, right? That's what our slope does. As we're graphing, right? Is our line going up or down? How much is it going up or down? When the rate of change is positive, the linear function is increasing. All right, so when this coefficient of x, our slope, our rate of change, when it's a positive number, our linear function's increasing. It should be, right? We're paying 25 cents more per song. So how much we're paying is going up. So it says, in other words, increasing indicates that as the x value increases, so does the y value. The more songs you download, the more you're going to pay. Okay? Unlike when the rate of change is negative. When the rate of change is negative, the linear function is decreasing. Okay? Decreasing indicates that as the x value increases, the y value decreases. Whoa, whoa, whoa. How is our x value still increasing? But think about it. When we read graphs, we always read them from left to right. They're always increasing. All right? And sometimes our line is going up, and sometimes our line is going down. Okay? So if it's going down, the y values are decreasing, but the x values are still increasing. So it's kind of like as time goes by, what's happening? Okay? Things are either increasing with you or decreasing. The constant value is referred to as the initial value or y-intercept. And that happens when x is 0, which we've been talking about, right? Where are we hitting that y-axis? All right, so again, what we're focusing on now is we're diving deeper into functions, into our slope-intercept form. And we're not thinking of it as now just being as the y-intercept and the slope, but we're gathering more information from it. What's our initial value? How much is our function increasing or decreasing? And those are the type of things we're going to be dealing with in this lesson.